so today we're going to start algebraic proofs, which proof is just going to mean that you are providing reasons to back up while you're solving something, okay, or while you're showing that something is true. So a proof is an argument, and we're going to need our highlighters. So it's an argument that uses logic, definitions, properties, and previously, and this should say proven statements, to show that a conclusion is true. An important part of writing a proof is giving the justifications to show that every step is valid. Okay, so those justifications are very important. For each justification, you can use a definition, a property, or even a postulate. So many of these properties you already know and you're going to use naturally when you're solving equations, such as like what we did early with the addition, subtraction, multiplication, and division. And we're going to add those to our word bank now. So some of the ones that we've already been working with, we're going to add to our list. So you're going to put your name on it. So just like earlier when we were solving an equation, we use certain properties. There's a property for our most general operations. So there's the addition property. And it's of equality. So you use it when you have an equal sign. Usually we'll abbreviate, we'll just say addition prop of equality, and you can put the equal sign. You also have the subtraction property. So like I said, you can write the subtraction property of equality. You have the multiplication property of equality and the division property of equality. What's another one that we use today? Yes, good. And you can just put distributive property. Right, so we are going to keep adding to this, but this is going to be your word bank for your proofs. So when you have to put in a reason, you can use this word bank to help you figure out what the reason is or justification for your step. Now, there's a few properties that we're going to learn about today that I also had you define on your definition sheet, which I'll hand back to you. And these are the reflexive, symmetric, and transitive properties. And there's two of them. There's the of equality and there's the of congruence. One is going to be used when two things are equal. The other one is going to be used when we have congruence. So the properties is the first one we're going to talk about is the reflexive property. Okay, and that is going to be like a reflection. Because you're looking back at the same thing. So if it's of equality, you might have something where A is equal to itself. If it's of congruence, it would be, you could have like a segment is congruent to itself. EF is congruent to EF. Okay, so it would be the same thing equals itself. Okay, so it's equal to itself. The next one is the symmetric property. So some of you wrote down the definition for symmetry, which is a little bit different than the symmetric property. Okay, the symmetric property is going to look like a flip. Okay, so when I say that, it's going to look like if A equals B, then if we flip those around, it would be B equals A. Okay, so that would be the symmetric property. If A equals B, then B equals A. You could also have, if it was congruence, if angle 1 was congruent to angle 2, then if I flip those around, angle 2 would be congruent to angle 1. Okay, and then the last one is the transitive property. So transitive property, and that is going to be a transfer. So that's when you're going to have multiple variables, so not just two like in the one before. So this would be if A is equal to B and B is equal to C, then, well, if A equals B and B equals C, what else has to be equal? A and C. Right? And then if we had something that was congruent, we could say if PQ was congruent to RS and RS is congruent to TU, then PQ is congruent to TU. And so again, I just want to stress the difference between these two is just what symbol you have. So if it's of equality, you're going to have an equation that has the equal sign. If it's of congruence, then that's when you're going to have the congruent symbol. Okay, so we are going to put these on our sheet. Okay, and then I'll come back to this if you didn't get everything written down. Okay, so we're going to have the reflexive property, and we're just going to put of equality or congruence. Okay, so whichever you have, equal or congruent, that's the one you're going to use. And then you have the symmetric property of either equality or congruence, and the transitive. Sorry, my T looks a little weird. So the transitive property of equality or congruence. Okay, and then another one we're going to put on, it's going to be this next one. So it says the blank property is used when blank, blank, blank. So the substitution property is used when you substitute or you plug in one value for another. Okay, for example, if the measure of angle 2 was equal to 80 degrees and the measure of angle 1 plus the measure of angle 2 was equal to 180 degrees, do you think you could do the substitution? See if you can write out what the next statement is, or at least just think about it. Do you think you can do the statement? Yeah, okay, Matt, tell me what you got. Yeah, did you do it?
I just got one measure 1 equal.
That. Oh, well, you're going to write down your statement. So you're going to plug this in. Does anybody else think they got it? The statement? Yeah, Julie?
I just said the measure 1 is 80 degrees.
Okay, so you're going to plug this into your equation. So it's going to be the measure of angle 1 plus, and then if you're doing substitution, right, instead of the measure of angle 2, what's the measure of angle 2 equal to? 80. So 80 degrees equals 180. So you wouldn't do the measure of angle 1 equals 100 until the next step. So first you'd have to do this by substitution.
So we're not even going to answer?
Say it again.
So we're not going to answer?
We're not gonna. If this were a proof, you would just have another step to it. Okay, and then so the next one we're gonna put on our chart is the substitution property. Okay, you can also just write substitution. It is important when you do your proof that you write it out. Because if you just wrote sub, subtraction starts with sub as well. Okay, so make sure that you're writing out your substitution. All right, and then we're going to go to the next page. Which is our 2.5 examples. So it says to solve the equation -5 equals 3n plus 1, you're going to write a justification for each step. So whenever we do this, we're always going to start with our original equation. Okay, so we're going to solve this, and then we have to write a justification for every step. So the first step, -5 equals 3n plus 1, that was given to us. So our justification is just going to be given for the first one. Okay, you'll notice that in every proof, that's what you're going to start with.
I didn't get it.
Put it right on the back there. Okay, and so now we are going to solve this. All right, so Abby, what am I going to do first to solve this for n? Yep, so I'm going to subtract 1 from both sides. Okay, so I'm going to do that, which is going to leave me with 3n equals -6. So what you're going to do is write a justification for how you got from this step to this step, and we did subtraction. Is this going to be of equality or congruence? Yeah, how do you know, Matt?
I don't know, I just guessed.
Yeah, because you have the equal to. Okay, so the other one is congruence, right? So if you have a congruent symbol, that's when you'll use congruence. Okay, and then Rhea, what am I going to do next to solve for n?
Divide -6 by 3.
Okay, and you're going to do both sides, so divide both sides by 3. So when you do that, you will get n is equal to -2. So then your justification, you just say, all right, I divided, so that would be the division property of equality. All right, what questions do you guys have for me on your first example? That one's not too bad. All right, let's look at example 2. So it says, what is the temperature in degrees? It actually says degrees. Bless you. In degrees Fahrenheit F when it is 15 degrees Celsius. Solve the equation and justify each step. Okay, so there's a couple different things we have to do here. It says, what is the temperature in degrees Fahrenheit when it is 15 degrees Celsius? But then we also have to solve this equation and justify each step. So we're going to start by solving the equation, justifying each step, and then we'll answer the original question. So I'm going to start with F is equal to, this should have a C in it, like that. So will you guys put that in your equation? 9/5 times C plus 32. Okay, and your first step is always going to be what as your justification? Given. Good. So this is given to you. Okay, and then we're actually going to go ahead and we're going to plug in our 15. So it tells you when it is 15 degrees Celsius. So we're going to plug that into our equation. So we have F equals 9/5 times 15 plus 32. All right, so if you plug that in for C, what's our plug-in justification? Yep, good, substitution. Okay, so we're just going to write substitution. Okay, and now we're going to go ahead and simplify. So when you do this, when you multiply 9/5 by 15, I'm just going to show you how you can do that without a calculator. Because for 9/5 times 15, what's 15 divided by 5? 3, right? So what you can do is 15 divided by 5 is 3. So 9 times 3 would be 27. So this would be 27 plus 32, which is 59. So this would be 59 degrees. Okay, now the justification again for these two steps, really all three of them, is going to be to simplify. And let me tell you why. Okay, so the reason why this is simplify and not multiply is because if you use the multiplication property, you have to do that to both sides of the equation. When you're just simplifying on one side of the equation, you are going to use the reason simplify. So so let me show you the difference with what we did up here. When we did the division property, you're dividing both sides by 3. Here, we aren't multiplying both sides by 9/5. We're just simplifying what we already have. Okay, so your justification is just going to be simplify. All right, and then for the last one, example 3, we are going to write a justification for each step. Okay, now they've already done the solving for us. We just have to find the reasons that allow us to solve this. So in this case, your given part is anything that is in your diagram. Okay, so your diagram is what is given to you. Now let's look at this. This should seem familiar. It says NO equals NM plus MO.
Why is there an equal sign on it?
Yeah, there's no equal sign.
It's right there.
No, below. It's just.
Oh,
addition.
yeah, that should be. Yeah, we'll fix that when we get there. Okay, so for this one, does anybody remember what special thing that is? Yeah, come. What's this called? NO equals NM plus MO. Yeah. What is it? Nope. So if it's transitive, it'll have to be,
Oh,
there'll have to be like 3 different things are equal. You're transferring the equality. Yeah, Ireland, you know? No. Because reflexive, it has to be equal to itself. No, it's not on our list yet. What is this? No, it's not given. So it's saying NM, this piece here, plus MO equals NO. So it's saying this segment plus this segment equals the big segment. Uh-huh. No, but it's getting closer.
What did that say?
He said something about the midpoint. Nope, it's not a bisector, right? Does it cut it directly in half? Yeah, let's look in our notes.
addition point,
Nope, but you're getting warmer.
midpoint.
It's not a midpoint.
I said midpoint, nice try.
Yeah, it said midpoint.
Sorry, I'm naming off things on their notes.
Naomi, you have it right there.
Isn't it the segment addition postulate?
Yes, it's the last one that you guys had on your definitions. This is the segment addition postulate. The segment addition postulate. Okay, so we will add things like this to our word bank today as well. Okay, so the segment addition postulate is how we know that NM plus MO is going to be that whole line NO. And then, yes, you should have your equal sign. It should say 4x minus 4 equals 2x plus 3x minus 9. Okay, so then what we have to do is ask ourselves, how did we get from this step to this step? How did NO become 4x minus 4? Yeah, Julie? Yeah, what is it called when you replace it? Substitution. Good. So this is our substitution. Okay, so then now what you're asking yourself is, okay, how did they get from this step to this step? So a good thing to do is look and see what changed. Did anything change on this side? Nope. The only thing that changed is this became 5x minus 9. So think about where the 5x came from. Yeah, you added the 2x and the 3x on the one side, so that would be what? Simplify. Yep. Why is it not addition? Good. Okay, so it has to be simplified because you did not add to both sides. Okay, once you get here, just think about what you would do. right? We'd need to get all of our x's on one side. So it used to be 4x minus 4. Now it's just negative 4. So how would you move 4x over? You would subtract it. So this is just going to be the subtraction prop of equality. And then for the last one, we have x. We used to have x minus 9. So how would I move over that minus 9? Addition. So this is going to be the addition property of equality. Okay, so you're always asking yourself, okay, how did I get from one step to the next? Okay, so then let's go ahead and write some more things on our sheet. Okay, so one other thing we used was simplify. And then we're also going to just put like some little hints on the side. So for simplify, when you're simplifying, that's when you are combining or evaluating on one side of the equation. Right? The ones at the top here, this whole group is going to be when you either add, subtract, multiply, or divide on both sides of the equation. Okay, your distributive property, that's when you have the parentheses. You can just write distribute with parentheses. Okay, your reflexive, we said it was like a mirror because that's when something is equal to itself. Okay, the symmetric property is when you have the flip or they just switch. Okay, and then for your transitive property, let's go ahead and write that it is like if A equals B, B equals C, then A equals C. You have two equalities, which means the first and the last are equal to each other. And then for substitution, this is when you plug in a value. Okay, so then let's go over some of the other ones that we're going to have. So one of them we used is the segment addition postulate. Okay, when you have the segment addition postulate, be like you have A, B, C. AB plus BC equals AC. Is there another addition postulate that we have? Is it only for segments or does it apply to something else?
Angles.
Uh-huh.
Yeah. We could do like an angle addition postulate.
Yep, so we have the angle addition postulate as well. So we can call this A, B, C, and D. So angle ABD plus angle DBC is going to be equal to angle ABC. Okay, there are a couple of other things that you guys already mentioned. You did mention the midpoint. The definition of the midpoint is something we are going to put down. So we'd say definition of the midpoint. And we would use that when we know we have a midpoint. What does the midpoint do to the segment? Cuts it into two equal pieces. So the definition of the midpoint would be used to say that the segment AM is congruent to the segment MB. We could also use the linear pair theorem. We'll talk about that tomorrow. We'll actually add a few more of them tomorrow. Let's actually we'll write them down today and then we'll define them tomorrow. So there's a linear pair theorem. There's also going to be the definition of supplementary angles. And if we're talking about supplementary angles, there's also what type?
Complementary.
Yep. And complementary is with an E. There's the definition of an angle bisector. There's the vertical angles theorem. Oh, if it's a theorem, I'll usually abbreviate THM. You can also just write it out, theorem. There's the definition of congruent angles. And the definition of a straight angle. Okay, so we're also going to write down your homework for the day, and then I'm going to show you how to put these in your notebook. Okay, so for 2.5, this is going to be on page 107. We're going to do 16 through 21, 23 through 28, and 30 through 32. And then, like I said, I'm going to help you put this in your notebook. Okay, so this will be a new entry. Bless you. New entry. Shh. Okay, so 2.5. You guys have the title at the top, which is algebraic proof. And then this is going to go on the right side of your notebook. We are not going to put in the Chapter 2 word bank. Okay, so I want you to keep that outside in your folder. That way you can use it easily as we add to it. Okay, and then notice I did not put anything on the back of this. And that's so that you guys can, and you can decide which way you want to do this. If you guys want to glue it in this way so that it folds up, you can do that. If you want to glue it in sideways, if it doesn't fit that way, and fold it in half, you can do that as well. What I would do is fold this right underneath here. Your reflexive.
Is it okay to fold it in some way so you just glue it all into one?
Yeah, you are going to glue it all as one. Yep, so either this way. So if you want to open it up and be able to see it like that, that's perfectly fine. Or sideways. So if you want to open it up this way, you can. Okay, so one of those two ways. And then you can put this directly on the back. And then again, you can decide if you want to. Again, I would just fold it right after the first example. Okay, and then if your notebook is wide enough where you can just put it in this way, you can go ahead and paste it there, or you can paste it sideways if your notebook is a little bit thinner. Right, so then you just put your glue on the back of the page that you're gonna glue it down. And then this is a front to back. And then again, we are not putting the word bank in there. Okay, so that is your front and your back.